Hi students, today we're going to be talking about balancing combustion reactions, and there is another video on combustion reactions themselves, but today we'll be talking about balancing. And so before we get into this, I do want to talk about real quickly the law of conservation of mass. Now, what the law of conservation of mass says is matter cannot be created, matter cannot be destroyed, matter is only rearranged into new compounds. And really where this comes in with this particular aspect of balancing combustion reactions is this says that there needs to be an equal number of atoms present on the reactant side and present on the product side in a chemical reaction. And if you don't know what reactants and products are and a chemical reaction looks like, you definitely need to go back and watch the video on combustion reactions itself, where I review some of these types of things, as well as the video that I posted regarding chemical reactions. So let's get into what's going on with balancing and just kind of how to analyze one of these combustion equations. So I'm gonna write a real simple combustion equation here real quickly. And so this is our combustion equation, and just a reminder to you that these combustion equations, we do have a hydrocarbon, real simple hydrocarbon, CH4, burning with oxygen to produce carbon dioxide to produce water. These three pieces right here are going to be pretty much the same for most of these reactions that we see. The only thing that's going to change is the hydrocarbon, which is this guy right here. And so before we dive into this, into the laws and into the rules governing balancing combustion reactions, I do want to take a moment and just count some atoms here. Let's just do some atom counts. So first off, on our reactant side, we're going to count, first off, the number of carbons. And as you can see right there, there's just C, and it doesn't have any number right down there, so that we make the assumption that that's just one carbon there. And on the other side, the same goes for right here. There's just one carbon there. So we would say that the carbon currently is obeying the law of conservation of mass. It's actually, there's equal numbers of carbons. And you just think about kind of how this arrow is sort of our dividing line, making sure that everything to the left is balanced to everything on the right. Let's look at the hydrogens next. You can see there, the arrow I'm pointing to, there are going to be 4 hydrogens there. 4 hydrogens. And then over here on the product side, you can see that in this water molecule, there is only 2 hydrogens. And so these are unbalanced. Somehow we've lost 2 hydrogens. They've gone. And then if we look over here, we have our oxygens, and hopefully you can recognize that there are 2 oxygens. And over on the product side, we have 2 oxygens right there, but we also have to remember there's 1 additional oxygen right there. So there's actually a total of 3 oxygens on the product side and only 2 on the reactant side right here. So we would say this reaction, as written, is unbalanced. It does not have equal numbers of reactants and products. So I'm going to talk to you about the rules for balancing super fast here. So here we go. Before I dive into the rules, I do want to mention something super fast that's going to really help you. You may have noticed that I threw like a line here and a line here and a line here and a line here. Those are places we're going to put numbers, and they're called coefficients. I'll get into what that means in a second. But let me just say something really quickly here. If I have a number, like let's say I have 2CH4, what does that number actually mean? Well, what it means is there's actually a CH4 and then another CH4. It means we have 2 actual CH4 or methane molecules. Now, if we were to count up all of our atoms in these two, you could see that for the carbons, we would have a carbon there and a carbon there, so we would have 2 carbons. And then if we were to count up the hydrogens, there's 1 there and there's 1 there. Actually, there's more than 1. There's 4 and 4. So we would have 8 hydrogens. So that's one way to look at these coefficients that we're going to be talking about. The other way is we could multiply through. We could just say 2 times 1 for 2 carbons, or we could say 2 times 4 for 8 hydrogens. Hopefully that's clear, and that's what we need to know before we really get into this. So, okay, let's talk about some rules for balancing super fast. Now, these rules are specific to combustion reactions. So some of the general rules, though, are the same. So this is a rule. The first rule is really for any chemical reaction, including combustion reactions, and that is we are going to use whole numbers as coefficients. And those are just going to be those numbers that go in those spaces that are in front of each of the atoms or molecules. So let me kind of jump back up here. The coefficients are going to be, you can see my arrow, they're going to be placed a number here, a number here, a number here, or a number here. Those are going to be the coefficients. And when we say whole numbers, what we're talking about is we are talking about numbers that are not fractions and they're not decimals. They're a whole number like 1, 2, 3, 4. Okay, and one additional thing that we need to know about these coefficients, these numbers, is they should always be in the lowest ratio. Meaning, if we can reduce, we should reduce. And what do I mean by that? Well, what I mean by that is if we go back up here to this chemical reaction that we had, and let's say hypothetically we had the number 2 here, and the 4 here, and a 2 here, and a 4 there. Those are all divisible by 2, and so we would divide all of them by 2 to reduce them. If we had, like, let's say a 1 and a 3 and a 5 and a 1, those are not divisible by the same number that will reduce them. They're all divisible by 1, but that doesn't change anything. Okay, just wanted to make sure that was clear for everybody. So we want whole numbers in the lowest ratios. Another rule is going to be if it's a combustion reaction, we're going to use what's called the rule of Cho. And what the rule of Cho says in a combustion reaction is we always balance carbon first, we balance hydrogen second, and we leave oxygen for the end. So just keep in mind the rule of Cho for combustion reactions. Now, this rule is specific to combustion reactions. If we were just balancing a regular chemical reaction or that's not a combustion reaction, we would not follow the rule of Cho because we wouldn't necessarily have carbon and hydrogen and oxygen present in that reaction. So let me talk about a couple examples of what we're talking about here. So let's go back to that original reaction, which is going to be methane burning with oxygen to produce carbon dioxide and water. And let's apply the rule of Cho and balance this guy out. So we're going to start with carbon. And so we have 1 carbon here, as you can see. And on the other side, on the product side, we have 1 carbon. So carbon is currently balanced. I'm going to leave carbon alone. I'm then going to go to hydrogen here, and I have 4 hydrogens here, and I only have 2 hydrogens here. So essentially, I need a number that's going to be placed here when multiplied by this 2 gives me 4, so that I have equal numbers of hydrogens on both sides. And hopefully you can see that a number that's placed here then multiplied by 2 that equals 4, hopefully you can see that number is going to be 2. Because once again, 2 multiplied by 2 is equal to 4 hydrogens, and we have 4 hydrogens, so now hydrogens are balanced. And oxygen always goes last, and so we have oxygens on this side, there's 2 there, but over here we have 2 oxygens as well, and then we have some more here. So obviously, sometimes I'd like to write the oxygens down just to keep track of them. There's going to be 2 in the carbon dioxide. Right here, this 2 is going to multiply through to the hydrogen. It's going to multiply through to the oxygen. Now, there's only 1 oxygen here. You know, we don't necessarily write the 1 down here, but it's there. And so really, this is 2 times 1 for this water, and so we have 2 oxygens there. Now we're going to add these 2 together, and so we get a total of 4 oxygens for the product side. we're going to come back over to the reactant side right here, and we have 2 times what number equals 4? Well, hopefully you can see that that number is 2. And so anything that's left blank, we're done now. Anything that's left blank, we're just going to put a 1 there, or we can leave it blank. Either way works. So really, our coefficients for this balanced equation are 1, 2, 1, 2. And that is how we balance a combustion reaction using the rule of Cho, using whole numbers and the lowest whole number ratio. I'm going to do a couple more. You might want to try these, pause the video, and see if you can do them without me walking you through, and then press play on the video and to see if you got it right. So now would be a good time to pause the video if you want to try this one by yourself. Okay, so I'm going to start with carbon first. Carbon, there's 3 here, and there's 1 there, so I'm going to go ahead and place a 3 in front, just like that. Now I'm going to go to hydrogen, because rule of Cho, hydrogen is second. We have 8 here. We only have 2 here, so we're going to put a number that when multiplied by 2 gives us 8, and that number, hopefully you can see, is going to be 4. I'm now going to add up my oxygens, so I have 3 times 2 oxygens, so I have 6 oxygens on the carbon dioxide, and then I have 4 times 1, I have 4 oxygens on the water. Add those 2 together, I get 10 oxygens. And then I'm going to look back over here, and what number times 2 equals 10? Well, hopefully you can see that number is 5. And that is how we do this type of combustion reaction. So 1, 5, 3, 4 are the correct formulas. Hopefully you're starting to get this now, and there's going to be a bunch of practice problems. I want to show you another type of equation that comes up, another type of reaction that comes up, and how to attack this issue that it might pose. This issue that comes up involves an equal number of carbons in a simple hydrocarbon, an equal number of carbons. And so everything else works the same way. Let me get rid of that 10. Hope it's not going to let me get rid of the 10. Just to get that out of the way. Okay. All right. Now, this one works the same way, except till we get to the end. And here's what we're going to do. Start with carbons again, rule of Cho. 2 carbons, put a 2 there, just like that. We have 6 hydrogens. What number multiplied by 2 gives us 6? Well, hopefully you see that number is 3. Now I'm going to go ahead and total up all of my oxygens. I have 2 times 2 for 4 oxygens. And then I'm going to go to my water. I have 3 times 1 for 3. So when I add these 2 together, I get 7 oxygens. Now, the question becomes, what number would go right here when multiplied by 2 gives us 7? What number multiplied by 2 gives us 7? And you might be thinking to yourself, there's no whole number that when multiplied by 2 gives us 7, and you'd be correct. There is a decimal, though. We could put 3.5. I'm going to go ahead and put that in there, even though it is not allowed by the rules. The rules say it's got to be a whole number, no decimals. The reason I put that there is because I want to do something to get rid of that decimal. And what I'm going to do is I'm going to multiply the entire expression by 2. Now, when I mean multiply the entire expression by 2, I mean I'm going to multiply 2 by just the coefficients. 2 times 1, 2 times 3.5, 2 times 2, and 2 times 3. So let's go ahead and do that. So I'm going to go ahead and cross these guys out. So 2 times 1 is going to be 2. 2 times 3.5 is going to be 7. 2 times 2 again is going to be 4. And 2 times 3 is going to be 6. And so now those are my new coefficients, 2, 7, 4, 6, and that is balanced. And I can double check that it's balanced by multiplying here 2 times 2 for the carbon, which gives me 4. And over here I have 4 carbons. 2 times 6 for hydrogen, which is 12. And then on the other side, we have 6 times 2 for hydrogens, which is 12. And then 2 times 7, which is 14. And we have 4 times 2, which is 8, plus adding in another 6, that gives us the correct number. So now that's balanced. So that's the way to attack 2 of these problems. So this is a way to balance those equations to meet, balance those combustion equations to meet the law of conservation of mass. I hope that helps.